Hi guys, this lesson is what I'm calling more logarithm basics. So the first thing that we're going to learn about is how to evaluate logs that look like these here. Now with the first two, it's kind of an interesting situation. Remember that you're asking the question, 5 to what power is 5 to the x? And so it should be obvious now, since these bases are the same, just like we were doing in our previous lesson, the missing amount has to be x. Okay, so our answer to this is simply x. Okay, so there's our x. And we can think about this as if like the 5's here were canceling out almost, and you're down to that x, or the log base 5 and the 5 cancel. All right, if you look at the next one, log base 4 of 4. So 4 to what power is 4? Well, obviously, that would be a 1. 4 to the first power is 4. Now, the last two, again, let's look at kind of the way we did last week and get our bases to be the same. So we're saying 2 to what power is 8? So if I go back to my scrap paper, I've already done this one. 2 to what power is 8? Well, I can think of 8 as 2 to the third power. So what power am I missing? A 3. So my answer to this question will be 3, because 2 to the third power is 8. Now, for the fourth one, I'm doing natural log, because I have an e, 1 over e. So this is saying e to what power is 1 over e, and I accidentally tapped this one in. So let's look at this on the paper and see why. So we're saying e to what power is 1 over e? Well, we have to remember that 1 over e can be written as e to the negative 1 power. So the question becomes, what power am I putting on e that will make it e to the negative 1? And obviously that is a negative 1. Okay, so that's where we finish up on that. Now, for these next few problems, we have some numbers in front. I'm still going to come up with the answer for the log part the way that I've been doing it. It's just that this number in front now means I'm going to multiply by whatever that is. In the first case, that will be 5. So I'm asking 3 to what power is 1/9? So I want to get this 1/9 to have that same 3 as a base. So I'm thinking 3 to what power? And then I want to think of the 9th as 3 squared. But it's on the bottom of a fraction, so that'll make it 3 to the negative 2 power. So my answer to that log part is a negative 2. But because our problem was 5 log base 3 of 1/9, and I've now determined that this part is negative 2, I still have the 5. So I'm going to do 5 times negative 2 and get negative 10. And this is my overall answer for the problem. For our next problem, we're looking at 4 natural log 1. So again, I'm going to ignore the 4 for a minute and think about this log. Because it's a natural log, I know that there's an understood base e. So my question is, e to what power is 1? And as you remember, anything to the 0 power is 1. So I know that natural log 1 is 0. If I bring down the 4, 4 times 0 is 0. So my overall answer here is 0. Okay? And then finally, we have 2 natural log e. So I first want to concentrate on the natural log e. Because it's a natural log, I know there's an understood base e. So I'm saying e to what power is e? Well, we know that is an understood 1 power, so the power that's missing is a 1. Since 1 is the answer to this natural log e, and I bring down the 2, I'm going to multiply 2 times 1 and get 2 for my overall answer. Okay, so that becomes a 2. All right, now, what's interesting about this is that if you have an exponent that is a log, if the base of that log matches the base of your whole kind of exponential look, then you can almost think about canceling those out. And there is math behind that, but for right now, we're just going to look at it as a canceling out situation. All right, so I pulled these problems over where I can write, and so if this 13 here matches the 13 on the log, I can cancel those, and my answer would simply be 6. The same thing happens in number 9. 7 is our exponential base, and the base on our log. Those cancel. My answer is 14. And then finally, you may not think about this last one, but remember, because it's a natural log, I know there's an understood base e. So those match. If I cancel this part out, I'm left with a 3, so my answer here is a 3. So again, if you look for these matching bases, then you can just simply cancel and bring those other pieces down to the regular level. All right, we also want to make sure that you know how to type these things in. And I will be showing you in person how to type these into the TI-84, but I also want to show you how to do these in Desmos just to make sure everybody knows how to plug these in. So I'm in Desmos, and I want to find the log of 6,230, I think was the number. You want to go to the little keyboard at the bottom, and to Functions, and to Miscellaneous to find log. So you have the choice here of regular log, which is understood base 10, or log with a subscript base. Now because ours is a regular log with a subscript that's just an understood 10, I can hit just this and it pop up. But I also want to show you that I could simply type in the letters log and it understands what's going on. I do want to put in parentheses the, I think 6230 was what it was maybe, that just type in and we'll get this decimal here. Now the second example was a natural log, and let's look back at it. It was natural log of 0.4209. Natural log, you may have seen it, was over here as well in the functions miscellaneous, but you can also type ln, and you're understanding that the Desmos will understand that you are meaning natural log. So this was 0.4209. Want to make sure I'm in the parentheses, and I can get that numeric decimal answer here. And again, I'll be showing you how to do these in class in the TI. All right. Now finally, we want to look at some simple equations. And the way that we're going to solve these is by writing in exponential form. So first, I'm going to look at this equation, and I'm going to write it in exponential form. So this is a regular log. I know it's an understood base 10. So I'm going to say 10 to the power of negative 3.864 equals x. Now these, I said, were simple because at this point all you need to do is type this into a calculator or into Desmos and come up with an answer. So I'm going to do that. Now I am using a TI and I get 1.367, but you'll notice over on the end it says E-4. So that means scientific notation times 10 to the negative 4th power. Okay, let's see what happens in Desmos. So when I type in 10 to the negative 3.864, it actually gives me the whole decimal not in scientific notation. But you'll notice the first numbers are 1 and 3 that you come to that are not zeros. And if you move that decimal place 1, 2, 3, 4 to the right, which is the negative 4th power, you can end up with that scientific notation that I was discussing. Either way is an acceptable way to write this answer for me. All right, so let's look at 14. We want to write this in exponential form. It's a regular log and the base is not written, so it's an understood 10. So I'm going to say 10 to the 12.86 power equals x. Then I'm going to type that in. So I'm going to type 10 to the 12.86 power. And this time it gave me scientific notation. So 7.244 times 10 to the 12th. And that's probably a good one to leave in scientific notation because the 12th power would mean I would take this decimal and move 12 places to the right. And that would be a very, very large number to deal with and look at. So we'll just keep it in scientific notation. Now, the last example we had was a natural log, and so that is an understood base e, but we're still going to go with exponential form. So e to the negative 30.8316 is going to give us our x, and so I'm going to type that one in. So I went ahead and used my calculator and got 4.07 times 10 to the negative 14th. And so I could have gotten that number in Desmos or in my calculator. All right, guys, that concludes this lesson. If you have any questions, email me.